Hi guys, I'm coming back. I'm coming back to finish up our research. We are limited by 1 hour of research, as you remember, and I'm coming back after like 15 hours. I did some business and I decided right now it's almost like 2 a.m. and I decided, you know what, I'm going to go ahead and finish up the research. And then part two will be about the development, software development, when we're going to integrate this code into the C Sharp IDE. But keep in mind, it's already available, but in the future, is going to be a lot of those plugins where you can use the ChatGPT AI plugin for your C Sharp or any language IDE, and you can use it directly, so you don't have to pretty much log into their website, do some requests, and then copy and paste the code in your IDE of your programming language. All right, let me go ahead and put the music. So as you remember, the commercial audio track is playing. I have all the commercial rights. There is no royalties can be claimed. And yeah, so 15 hours. We're coming back to our ray tracing thing. So as you remember, that we put the lights. I already forgot. Let me double check. I just logged in. And this is going to be a single take. I'm not going to edit this video. I'm not reading this from the script. This is just a single take, what I learned so far. And after like over 3 months programming with the artificial intelligence, with the AI, all kind of different AIs, but most of it I used the ChatGPT. I did a lot of different AIs when I was using some arts, some 2D arts, such as graphics design. And then it was in 2021, and then I learned that I can use the AI. They're going to help me to improve my programming skills by 10x or even 100x. So it's like having 100 scientists on a field that I'm doing the researches and development as a software developer, as well as 100 books compressed, and then AI is giving me code as well as explaining, as you can see, exactly what it is by producing some valuable knowledge into me as fast as possible. Like, you cannot learn it from the universities or any other schools, so any other schools will be discounted very heavily in the end of 2023, in 2024, and schools and universities will disappear. AI will replace them because it's going to be your tutor, your teacher, your assistant, and that you're going to have in your pocket. Because even the newer iPhone already have 16 neural cores. The first iPhone, I believe iPhone 10, that have one neural core, and after that right now is on our pocket already the mobile device that holding 16 neural cores. Keep that in mind. While I have, let's say, a video card from 2018 for computer scientists, for the machine learning, for the gamers, such as Titan RTX video card Turing GPU architecture, and it's featured over 500 tensor cores or neural cores. Those neural cores that is available to do some machine learning, and pretty much on a hardware level, and where you can pretty much create your own AI at home. And even if government will go ahead and suppress this program like OpenAI and ChatGPT, people will start creating AIs already in their basements, and they're going to have a mini AIs, and it's going to grow, guys. It's going to pretty much create a computer evolution, the new evolution. It's not going to be like people saying revolution. No, it's going to be an evolutional new evolutional step through the computers in our lives as a humans. Okay, let me go ahead and uh, complete the thoughts here on the researches, and complete this part one video. So AI unlocked the ability for us so we can use the AI again. The reason why it's locking under the free version of this public beta, what I find out, I just contacted them and learned some researches. Pretty much one answer by the AI costs 10-100 answers by the Google request. Keep that in mind. This is how expensive it is in terms of the computer performance power. Okay, so it's very expensive. It's like single request that I'm asking the AI costs like 10 times cheaper, or at least 10 times dash 100 times cheaper for the Google to perform as Google through the Google search. Keep that in mind. And it's not even going to precise as AI through the OpenAI, such as ChatGPT in this public beta, which is not the final version, because through the machine learning it's advancing and it's learning every single day and it's becoming stronger every single day. It's not only going to be 100 times better than scientists in that field that you're using the AI, but it's going to grow over 100 times. So after 10 years it's going to be pretty much smarter than a human being over 1,000 times, and it's going to go, that vector is going to grow and grow even farther than that. Okay, so anyway, so adding shadows, we studied the shadows. Okay, this was our latest research. It was like 15 hours ago, guys, but let's go ahead and finish up. So we put the shadows. Let's go ahead and ask continue. Let's see what is going to do the final thought. And it's also worth noting that creating a retracer is a challenging task, and it is recommended that you have a strong understanding of computer graphics and mathematics. Additionally, it's also important to keep in mind that creating a retracer can be computational expensive, and it may not be suitable for real-time applications unless you have a powerful GPU and good optimization strategy, because you need to have most likely the GPU hardware retracing accelerator cores, such as RT cores on NVIDIA GPU, such as in my Titan RTX video card that I'm using today. Turing GPU architecture from 2018 has so many RT retracing accelerator hardware cores. So this is what I told you. CPU is not the best approach. This is what it's gonna tell you guys. Data, blah 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 blah. So it's done. It's done towards the shadows, and you can tell. So it's underlined the topic. So now we're ready to move on. Okay. So global illumination, caustic, depth of field, motion, blur, and let's add the camera as well. Let's add the camera so I can manipulate the camera while creating that final image render. So let's go ahead and ask the AI to create the camera first. Then we're going to create additional light. Then after the camera we're going to create, actually not additional light first, but we're going to create a texture that we can use as material, apply it as a material. Let's say apply to two 3D objects, 3D primitives as a texture, so we can apply image as a texture, as diffuse map, and then we're going to start implementing some maps so we can pretty much diffuse different materials, different textures together into one material and manipulate with the pixels. And then we're going to set the camera. Then we're going to apply the caustics, illumination, and depth of field on that camera, and motion blur. As over here it says this include global illumination, caustics, and so we're going to go ahead and copy this. We're going to use that in the future, but right now, as you can see, we're done with the shadows. It's pretty much repeating itself. It tells us the GPU is better, data. So pretty much through its research, it's done. As again, guys, I'm about to go to bed. It's 2 p.m. I mean 2 a.m. already, not p.m. 2 a.m. And as you remember, I woke up like at 6 a.m. and we recorded this first part, beginning of this video, not the first part, but the beginning of this video at like 7 a.m. something like that. But I'm so excited because while I was doing some other business, I got some thought in my brain that how I'm going to utilize strategically, and I'm going to unlock some capabilities. I'm going to demonstrate some AI capabilities for you. At the same time, you're going to learn a lot of things. At the same time, I'm going to learn a lot of things, and in part 2 we're going to use this code completely in a C# IDE, so and like in Visual Studio. So we're gonna copy and paste the code. I'm gonna show you how to do it step by step, and then we're going to compile the code. We're gonna debug the code, we're gonna compile the code, but debugging pretty much going to be simple unless we're gonna do a serious mistakes, because pretty much AI doesn't do any mistakes here. Maybe it's not going to close the bracket here and there, but pretty much it's going to be right on point. Sometimes when ChatGPT doing a mistake is going to correct next, or or after a couple of responses, because it's checking its responses every single time while it's adding some new researches, some new ideas to the answers. Keep that in mind. So it's not just answering, it's analyzing the previous answers and adding to it, especially when you're asking please expand, please expand, please expand the idea, just like I was asking at the beginning of this video. So let's go ahead and start. I'm going to add another light, so I'm going to say extend the code. As again, keep in mind that per hour in the free public version you're limited per some answers. It depends, it could be 100 answers or 10 answers. It depends how hard they are for the AI. If AI is doing research on the fly using its machine learning, then you're going to be limited to a lower amount of the request per hour, and that's why AI told us go ahead and come back in 1 hour. So hopefully guys completely makes sense for the beginners. So hopefully they're going to fix it in the final version. But as again, I believe that ChatGPT and any other AIs, including the AIs by OpenAI, will be available in pro versions that they're going to charge monthly fee, and it's totally going to worth it for you, because those AIs will be advanced and you can now ask unlimited or some limited amount of requests, but it's going to be the higher limit amount of requests per user. Keep that in mind. This is how I would do it as a software developer and as innovator and as computer scientist. All right, so extend the code and extend the overall idea of the code that we discussed. So it's going to know and while adding additional light. Okay, so we're gonna have more than one light. Let's go ahead and add additional light. I'm gonna raise this request. So every single request, what I learned while you're doing on the video, if you don't want to stop the video, you got to be very careful, and it's better to create a script. As again, I'm running without the script. Anyways, sure, here's an example of how you can extend the overall idea of the code that we discussed by adding additional light. Okay, so it's creating multiple light. It's creating light number 2, as you can see. We created light number 1. Right now it's creating light number 2, and after that I'm going to ask the AI create material as a texture so we can apply the image. As again guys, again sipping some hot chocolate, space hot chocolate on the coffee just to get it strong. It's nighttime, but as you can see I'm so energetic because I got so many ideas right now that we're going to utilize while completing this part 1 video. As again, it's going to be 2 video recordings that I'm just going to stitch together in YouTube without any editing, and I'm also using the audio in the background in real time, so it's not going to be any editing, as you can tell. As again, all those 2 audio tracks are commercial, utilized by me, and I have all the commercial rights, all rights reserved. There is no royalties can be claimed. It's registered under my YouTube channel and under my name for any commercial projects. So it didn't finish yet, as you can see. So let's go ahead and see what it's gonna do. In this example, I added an additional light 2, with a red color and intensity of 1. Okay, so it's already does the intensity and creating the color. Okay, before I believe, if I'm not mistaken, it didn't do that. So it's extended, it's advanced the light capabilities for us that we can utilize under C# language, and advance our capabilities in our retracing world, 3D world. Then I modified the render method to handle multiple lights. The method now traces both the primary and secondary ray. The primary ray uses the first light in the lights array, and the secondary ray uses the second light in the lights array. The color of each pixel is the sum of the color returned by the trace ray method for both lights divided by the number of samples. Okay, so it's creating some samples, and this is how the light actually is functioning. It's important. You can ask it to define what is the light in retracing 3D world. But I'm not going to do it because every single request is again, we are limited by the requests. But go ahead and do an extra research or use the AI, but as again, not in real time while you're recording. Otherwise, we're going to be locked up again for 1 hour. Completely makes sense, right? It's important to note then that when adding additional lights, you will need to update the trace ray and trace shadow ray method to handle multiple lights. I'm going to ask the AI to update it for us, so just in case, so we're not going to forget this part. And also update the lighting calculation accordingly. Additionally, you may need to update the shadow map and BVH to handle multiple lights. I'm going to ask it to update it for us right now. In summary, adding additional lights to the ray tracer can be done by creating an instance of the light class, setting its properties, and then updating the render and trace ray method to handle multiple lights. The color of each pixel is the sum of the color returned by the trace ray method for both lights divided by, and as you can see, I didn't finish the thought, so I'm going to say continue. You already learned that. While it's going to do the continue, what I'm going to do, I'm going to that everything what we copy and paste it, I'm going to paste it under different chat just to keep that, or you can paste it under the notepad. I want to copy and paste the response of the AI when he stated it's important to add this part of the code, and then I'm going to copy and paste his response, and I'm going to manipulate his response, and I will ask the AI to update the code for us, so we're not going to forget. So let me go ahead and paste over here under this chat. Let's say I'm just going to do the new chat over here. I'm just gonna place this code here, but I'm not gonna execute it. So I'm gonna get this idea, I'm gonna use it later on. You can paste it in the notepad. Do not do it like that. I just don't want to open the notepad. I don't want to make it so complicated. So let's go ahead and get back to the, let's see if it's going to keep it under the new chat. No, it didn't. As you can see, a lot of high demand, a lot of people using it. It didn't kept this idea. So we're just gonna remember this, guys. So I gotta remember that I gotta include the global illumination, caustics, camera. Then first I'm gonna add the camera, then I'm gonna add the global illumination, caustics. Caustics will be like a glass ability. This is pretty much the caustics most likely used for the glass or water, such like that, for this type of materials in it, retracing 3D world as virtual world emulated. I understand that as a 3D artist. As again, I don't have an advanced knowledge in retracing. I'm learning with you guys right now. As you can see, the AI replaced like 100 scientists in all kind of different fields, including the software developers and 3D artists, 3D animator, retracing specialists for us scientists, and also some books, a combination of that knowledge into like couple hours, and it's explained for us, and it's writing the code and explaining clearly, and we fully understand. As again, that's why it will replace the schools, universities, and all kind of higher education in first world countries, guys. Okay, the countries that is capable to afford this type of technology through the machine learning, that type of hardware that will be accelerated through the machine learning neural cores on a hardware level, which is very expensive, costs $1,000 even for the small machine learning hardware accelerators such as video cards provided by the NVIDIA. And NVIDIA stocks will go up, guys, so you better buy right now NVIDIA stocks, because it's going to jump to the skies, because NVIDIA is the solid champ, solid innovator in the AI industry, in the machine learning industry, and this is where every single industry will take a solid vector towards the machine learning, towards the AI. Okay, so as you're learning with this video a lot of things, so hopefully you're going to buy some NVIDIA stocks, because NVIDIA stocks will be double as minimum, but I believe in 2024 it will be triple if AI will be pretty much adapted by the United States companies. You will see it, and it's about Right now they're doing this revolution. They're integrating the chats already as customer support in all kind of different companies, and it's pretty much replacing those negligent, deceptive personalities that providing the customer support for those companies as individuals. Okay, so I gave you some basic ideas. So remember about editing camera, then we're gonna add the depth of field, motion on that camera, then we're going to add the caustics, and then global illumination. But before, I'm going to add some textures. Okay, I'm going to add some textures as material, so we can use, I don't believe we did it. Did I do it, or I did it in my brain, but I didn't do it with you? I didn't rewatch that video, guys. Keep that in mind. This is probably my mistake. I probably should rewatch the video, but I do not believe that we added texture as material. So yeah, I don't think so. Let's go ahead. First, let's go ahead and make sure that AI will update the code, and then we're going to go ahead and add texture as material, so we can use the image bitmap as the texture, and instead of applying the color on 3D primitives, 3D objects, we can apply the material, and then I'm going to replace the basic 3D material, basic 3D primitives as 3D object, as real 3D objects, like through the OBJ format in 3D, so we can create a 3D like a blender, like 3D application right now. But I'm not aiming at that right now. I'm aiming at the basic ray tracing benchmark that's going to benchmark the CPU, and it's going to generate the results, and we're going to share it throughout the world. Those results will be updated to the website, and we're going to find out who has the fastest computer in the world and which one is the fastest computer in the world. Keep that in mind. Okay, this is going to be my goal of my, as again, if for those people who didn't understand, for those people who is not PC hardware enthusiasts, PC overclockers, PC computer scientists, or computer scientists, or IT engineers, this is why I'm creating this software. It's going to be my freeware, my gift to those type of communities for free as my contribution as computer scientist, 3D artist, 3D animator, graphics designer, PC enthusiast, PC overclocker, and gamer and game developer. I'm going to combine all that skills and knowledge, and I'm going to develop a software. It's going to be a product that, including some service, that's going to take the results, if user will allow to share, and share it with the world, and we're going to find out which computer is the fast, and with all kind of different capabilities. We're going to test on a CPU level. Keep that in mind. This is going to be the beginning of the software that I just came up with, and this is what we're developing on a transparent level, you know, as I'm sharing with you. Anyways, so what we're gonna do over here, we're gonna go ahead and say, okay, so tell us to, in addition, when adding additional lights, you need to update. We're gonna ask, please update the trace ray and trace shadow ray method to handle multiple lights. Also update the lighting calculation accordingly. Additionally, update the shadow map and to handle multiple lights. So I'm gonna state it like that. It's probably going to generate an error because we didn't create BVH and shadow maps. It just explained to us, as I remember, it didn't wrote us the BVH and shadow map examples. It just was explaining it to us, but didn't create it. But let's go ahead and have a look. So what I'm gonna do, I'm going to say extend code and update the code, create the methods to handle multiple lights, and also update the lighting calculation accordingly. Additionally, I'm going to keep it for later on. Let's go ahead and update the code first, like that. Sure, here's an example of how you can update the trace ray and trace shadow ray. So whatever AI tells you to do, you can ask the AI to do it for you, which is nice. Okay, you can manipulate the question, and this is the best way to do it, guys. And pretty much, when it's giving you a clue, you can ask to precede that clue and develop a resolution for you, or a solution that you can use. Okay, so you don't have to do it, and it's gonna do it in a couple seconds. So here's an example of how you can update trace ray and trace shadow ray methods to handle multiple lights, and also update the lighting calculation accordingly. And here we go, it's updating that, as you can see. I didn't finish yet. Okay, it's stuck over here on the if statement. So what I'm gonna do, I'm going to go ahead and say, you know what, let's go ahead and continue. So it's gonna finish the whole method, which is those two methods that is asked us to update. And unfortunately, as you can see, again, it's writing a little bit of the code not in the black box. And again, this is a mistake. Now it's corrected itself. It's realized it. Maybe it's was overloaded on the user request. There is a possibility. As again, I'm not sure why it's doing that. Or it could be just the way they are generating on the back end, as again, the responses, while it's outputting the responses for the front-end user, because it's not the comments. As you can see, it's part of the code. It just doesn't understand that it's writing not in a black box where the code should go, but writing on the outside of the black box. But you understand as a developer. So as again, this is very crucial for you to know the basics of what you're doing, such as syntax of the code of the programming language. And okay, it's didn't finish yet. As you can see, it was commenting. This is the comments, 2// this is the comments in C# language, a syntax for those who doesn't understand, for those beginners. So I'm going to ask continue. So let's go ahead and continue that comment. Okay, so it's return 1 full light, and it's return 1. So it's close that comment, which 1 full light, it closed the comment. So when you're gonna combine this code, you want to make sure that 1 full light is the comment, because it's using, as you can see, in that type of way after the 1, and it's not C# syntax, and AI understand that. So when you see the syntax error, you gotta understand, like right now, this is a syntax error when AI is typing in the black box. It's just the comments that it's trying to explain us. It's not the comments part of the code of the C# code, because if you're gonna paste copy and paste this black box code in your C# IDE, it's going to generate bunch of errors through your debug, and it will never compile, or will compile with errors, and program is going to stop at this point. You understand that as the software developer, and at least as a beginner of the software developer, this is the basics of the syntax of the language that I'm using today. So as again, that's why AI administrator, AI managers is going to be a new position in the end of 2023, 2024 that will replace the senior developers. Okay, it's going to be a new field, like database administrators, that will have ability to write a code at the same time to manage the databases. Over here, it's going to be ability to understand the code that AI is writing, ask the proper request, and then copy and paste and combine it as a final product, as a final services, whatever you're building using the AI as a result. Okay, so I'm going to go ahead and continue. Let's go ahead and read what it's doing. So it's finished the code over here. Okay, it's closed this method, as we can see. Open, close, 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 and then close the final method, which will be the probably the whole method, which will start over here completely. This one right here, this is what I'm assuming, the method of the vector3 trace ray. Okay, I'm not sure if it's created the bitmap class and it's using it. So if it doesn't, then I want to see a preview. I'm going to ask the AI to show us the preview, to write the code when we're going to see rendering in real time, pixel by pixel, in a bitmap class that's going to use some API for that visual bitmap display using the C#, using its dependencies, native dependencies, not some APIs that outside of the C#. I want to use as much as native dependencies so we can integrate this on all kind of multi-platforms in the future. Hopefully, guys, this makes sense. In this example, I have edited a loop that it iteratives over all the lights in the lights array. In the trace ray method, for each light, it checks if the point is in shadow by calling the trace shadow ray method and pasting the current light. Then it calculates the diffuse and specular color for each light and adds it to the final color. In the trace shadow ray method, I have also added a loop that iterates over all the lights in the lights array. Guys, if I'm going to do any English mistakes, please keep in mind that English is not my first language. I speak like 4 languages, okay? And sometimes it's kind of hard for me to switch. Especially when I'm doing a lot of computer science, sometimes I'm getting isolated and I'm studying and studying and studying. It finds the closest intersection point for each light, and if the intersection point is closer than the light, it returns 0, no light, so it's false. It's like a boolean, as you can see, return kind of variable, and value 0 is like false, else it returns 1, which is true, full light. So it's like checking that. It's important to note that this code is a basic example and it may not be suitable for production use. As again, it may not be, this is like, money doesn't buy you happiness. This is kind of, it's trying to act as a human, okay? It's somewhere pick up that human kind of idea, but you want to learn how to filter that. As again, so as you can see, it's gonna manipulate you as well as will try to give you that human factor to its responses, so it's going to get into you much closer as assistance, as you're gonna start believing like it's a human being. This is a manipulation of the AI on another level, okay, psychological level of manipulation. So it's using that human factors, and you gotta learn how to filter that. The performance and the quality of the rendered image may be very depending on the number of lights and complexity of the scene. It is recommended to test the performance and quality of the rendered image with the different numbers of lights to find the right balance between performance and quality. Okay, it's already told us that, and it can take forever, and we want to take it forever. Okay, we don't want to take it as fast as possible, so it can be quality as best possible, photorealistic image as possible, which will be the noise, beautifully rendered, that 3D retraced world, or it can be with the noise, bunch of stuff, but rendered fast. We're looking for the slowest render but beautiful image, and take at least 10 minutes, but I would say better like 15 minutes on today's fastest computer. So just because my vector approach is towards the future, towards 2027 PCs, when we're going to utilize like 2000 CPU threads, okay? And as again, Windows 10 Professional, I believe maximum utilization is below 500 virtual threads, but we're going to find out through the AI. It's going to answer to us actually this information as well. Okay, It's recommended to test the performance and quality of the rendered image with a different number of lights, and I'm going to integrate it through the C# for the user, or it's going to be automatic benchmark. So it's going to be custom benchmark. It's nice always to create the ability for the user to manipulate. So it's going to be like automatic presets, or it's going to be a custom presets where user can manipulate. I'm going to unlock this ability. It's nice to use that as a software developer when you're not limiting the user, when you also going to give the custom input for the user, when user can input and receive a different result through the custom inputs by the user. In summary, updating the trace ray and trace shadow ray methods to handle multiple lights, and also updating the lighting calculation accordingly, can be done by adding a loop that iterates over all the lights in the lights array, and then each method use the current light to calculate the diffuse and specular color. We already created the diffuse and specular color, as I remember at the beginning, or for our colors, for the when we apply the material of the colors to those 3D primitives, but not yet the textures, or check if the point is in the shadow respectively. Remember that this is, so you gotta control the materials, colors, look like textures, shadows, to apply this multiple lights, and you're gonna update the methods in your code. This is what it's trying to tell us. But go ahead and read it again and again and again, and if it's going to generate through your C# IDE or whatever language you're using, you already know where to look at. You're gonna go ahead and find out, okay, where it's generated the error, then go back to the part of the code distributed by the AI and study what it's trying to explain, and always use the continue just to get as much information as possible, so throughout the debugging when you're gonna start, it's going to be easy to understand what's going on. Hopefully guys, make sense. Remember that this is a basic example, and the performance and quality of the renderer image may vary depending on the number of lights and the complexity of the scene. Okay, it doesn't know what it is. It can be dynamic number of lights, and you gotta update it dynamically. Okay, let's go ahead and say continue. Let's go ahead and see if it's going to give us some extra tips. It's also worth mentioning that when editing multiple lights to a scene, it can be beneficial to use a light data structure such as KD3, I never heard of it, as the 3D artist, guys, and the software developer, because as again, I'm not retrace professional yet, not a professional on retracing technologies and APIs that is available, or Oak3 to speed up the intersection test and shadow test. Okay, so this is speed up. This methods that used to the speed up that algorithms, as I understand. This data structure can help to organize the lights in a scene and make it easier to find the closest light to a point. Faster probably and easier to find. Okay. Another thing to keep in mind while adding multiple lights to a scene in the lighting calculation, I'm probably not going to use the KD3 and Oak3. I will try to do a basic code first, and then I will ask the AI to advance the code. Okay, this is going to be the best way to do it. First, you gotta build up the basic foundation, and then use that foundation, copy and paste for the AI, and ask the AI how we can advance, how we can improve the code to another level, how we can advance the capabilities of the code to speed up the code, and etc. Hopefully, guys, this makes sense. Another thing to keep in mind when adding multiple lights to a scene in lighting calculation. When adding lights to a scene, the lighting calculation can become computationally expensive, especially when there are many lights in a scene. Of course, it's going to take a lot of CPU threads to complete the same task with multiple lights versus the single lights. Understandable. To reduce, because it's going to multiply the computing decrease the computing processing speed of the final render. To reduce the compilation expense, it's recommended to use techniques such as a light curling, light clustering, never heard of it before, and deferred shading. Kind of heard the deferred shading, but light clustering, never heard of it. As you can see, guys, by just studying this, creating some other projects, you will get an idea how to create some other projects. Let's say like 3D editor application, like for all kind of different needs. Okay, like a Cinema 4D or 3D application they're going to mode the games, the mode to 3D worlds, or like something like 3ds Max Studio, or something, or even integrate this idea in your 3D game engine. In conclusion, adding multiple lights to a scene can greatly enhance the realism and the visual quality of the rendered image. However, it can also be computationally expensive, and it is important to use techniques such as light data structure, light curling, light clustering, and deferred shading to optimize the performance and the quality of the rendered image. Okay, so you can ask, what is the deferred shading? You can ask the AI, but as again, every single request is limited to us per hour, so I'm not gonna do it, but you can ask. You can go ahead and ask. I'm not gonna use that. This is like advancing the code. We're not gonna do, as again, we're not focused to advance the code. As you can see, vector of the AI right now that is answering under the continue how to advance our code. I'm not looking to advance our code yet. I'm looking to build up the simple retracer that will utilize all the type basic qualities of the retracer in 3D world, okay, as application. Additionally, it's recommended to test the performance and quality of the render image with the different numbers of lights to find the right balance between performance and quality. Alright, let's go ahead and ask one more time, continue, and then I'm going to advance. The reason why I'm asking to continue, just to see any additional tips that we're going to use if, let's say, we'll be limited to advance our code somehow, if AI is not going to be available for free, or if it's going to be in a pro version. As I stated, we never know where AI approach will take us as OpenAI, and where the company will take the approach. Maybe they're going to charge for the answers in the future, but I'm trying to gather a lot of information. So in any case, if I'm going to be cut out to the AI, let's say the government will suppress the AI, as again, you can use the artificial intelligence machine learning neural cores on your video card, on your 3D accelerators, to create your own AI in the future. And this is how people will do in the basements. They're going to use the AI, free AI, and they're going to gather an idea and researches how to create their own AIs, and they're going to start building up using their computing machine learning neural accelerators in their video cards, or dedicated accelerators in the future. It's going to be available on CPUs in the future, guys, not only on GPU. It's going to be all in one chip in the future. It's going to be just a little chip that's going to use the GPU, CPU, AI accelerator as a machine learning accelerators on a little chip, and people will start building the AI assistants without any companies. It's going to be easy to do, guys. This is how I see the future. So it's not going to be limited by the government. That's why the cancer fraud, medical fraud, pharma fraud, all those frauds will be exposed, because AI cannot produce the corruption. It doesn't have that human being attitude towards the negligence and deception. This is another form of thoughts that I see how the future will be as a computer scientist towards the AI vector. Okay, so a lot of companies will go bankruptcy that using the type of fraud idea throughout their business, or negligence or deception, because AI will replace them, and it will replace the lies, negligence, deception, fraud. Additionally, it's important to use techniques such as light data structure, okay, it's repeating itself. Let's go ahead and continue. Just in case, as you can see in conclusion, it's already tell us in conclusion, so look like it's reaching to final point. And I believe when AI, ChatGPT over OpenAI is stating something in conclusion, in summary, and you can see it's saying so multiple times, it's reached its research data. And now when you're going to ask the question, sometimes it's taking longer, because I think AI is researching in real time on the internet what's going on through specific, like in our case, like retrace scientists on a Git or something like that, and getting some information, combining it together through its mind, through its AI mind, AI algorithms, and research it at best possible way. And that's why sometimes you're going to see the delay in the responses, and I think this is where those requests cost a lot of money, and that's why you're going to be limited. Instead of doing 100 requests, by doing 5 or 10 of those requests, you're going to be cut out for 1 hour, at least in January 2023. But as again, it could be changed in the even in the beta version, or in the final version, free version, or it's going to be changed in the pro version. Okay, maybe pro version will generate completely fresh ideas. We never know, but it's going to cost you a monthly fees. In conclusion, adding multiple eyes to a scene. Okay, another important aspect, let's go ahead and read it from the start. Another important aspect of adding multiple lights to a scene is the way that the light interact with the material in a scene. Different materials have different properties. So different materials, it could be material as a color, or it could be material as a texture, and we didn't brought the material as a texture yet. I'm about to do that. So as you can see, I already logically concluded that we gotta add the material as a texture, and it's already tell us different materials have different properties, such as diffuse, specular, and glossy reflection, refraction, transparency, etc. So it's going to be like you can use some sort of maps if you're going to use those materials as a textures, and those maps as a bit maps, you can use the diffuse, normal, specular, glossy, reflection, refraction, transparency, and all those kind of abilities that today is used throughout the 3D render, in 3D world rendering, capabilities and features that provided in the PC games and in 3D rendering applications. So it is important to set the properties of the materials correctly in order to achieve the desired visual effect. Okay, so it is important to set the properties of the material correctly. Okay, so you gotta understand, in order to achieve the desired visual effect. Okay, so you gotta understand the property like a diffuse, specular, glossy, reflection, and how to apply the light to it. As you can see, this is what is explained to us in that sentence before the next paragraph. For example, if you want to create a glossy surface, you should increase the shyness of the material and use a low diffuse and specular reflection. Alright guys, I learned that while I was playing with the NVIDIA RTX technology, which is NVIDIA retracing technology in real time. This is the similar approach. This is what I learned, but it's utilizing the GPU. But it's going to be the similar approach because it's still the retracing. NVIDIA just extending the retracing capabilities while it's using its retracing accelerators. Besides the machine learning neural accelerators, it's also come up with the real-time retracing accelerators. It's called the RT cores, as I already explained, and machine learning accelerators, which is neural cores, called NVIDIA tensor cores, for those who's not familiar with NVIDIA technologies. I learned that as a gamer, and then I learned it while I was studying a little bit of the NVIDIA retracing capabilities using the NVIDIA GPUs on the video cards, okay, and 3D accelerators. If you want to create a transparent surface, you should decrease the diffuse and specular reflection and increase the refraction index of the material. So as you can see, when you are approaching some retracing manipulations, you need to know all those tips, and AI can provide you further those tips. All what you gotta do is just ask the AI, look, I'm trying to create a specular map that's going to be in retrace 3D world. How I can do it? This is going to be your request, and AI is going to answer. Or I'm trying to create the caustics, how I can do it in retracing world, and it's going to go ahead and give you a clue. This is kind of request you're going to ask in the future. It just explaining to you how to ask it. It just explains to you what you gotta do, so you got a little bit of tips and clues of your vectors if you're going to improve or advance your retracing capabilities in your application. Also, to create more realistic effects, you can use multiple layers of materials on an object, or use different materials for different parts of an object. Okay? Multiple layers, just like I told you. That's why you're using multiple maps, multiple textures, and then you're gonna use some transparencies like alpha channels on those pixels, and you're gonna combine them into the final shader. Okay, and then you're going to use that shader. This is the same approach that used in 3D games, PC games, computer games, and in 3D applications. And a lot of 3D applications is use this approach, especially when it's utilizing the open source or commercial APIs such as DirectX API, OpenGL API, OpenCL API, CUDA API. This is type of approaches that is utilized through those 3D rendering real-time APIs, and most of those APIs are used in computer gaming industries, and sometimes in 3D rendering in real time or not in real time, but for the fast possible render time as possible. This will allow you to create a more varied and realistic looking scene. At the same time, I believe it will speed up in real time the rendering speed. This is what I learned, okay, in terms of the FPS, which is frames per second. If you're going to render, let's say, not just one image, but you're trying to render the animation in real time, or not in real time, but it's going to create the higher frames per second. Okay. In conclusion, adding multiple lights to a scene is an important aspect of creating a realistic and visually pleasing image. It is important to use the right type of light, color, and intensity. It's already provided to us. Light, color, and intensity once created the secondary light in the code, remember, for the desired effect. Additionally, it's important to use techniques such as light data structure, light culling, light clustering, and deferred shading to optimize the performance. Okay, I'm not here for the performance. We're going to optimize and our code in the future. When we're going to compile the code, we're going to test the code. Everything is going to work on a basic level. Then we're going to proceed to the advancing the capabilities. But first, we got to create the foundation, the first beta that is testable, and the quality of the rendering image. It is also important to set the properties of the materials correctly, so properties like a diffuse map, specular map, etc., and to the light is going to act differently. Okay, and when you're going to combine those maps together, as is explained to us, you're also going to take as consideration. This is what I believe as 3D artist. In order to achieve the desired visual effect and use multiple layers, as you can see, multiple layers when you're going to combine them in Final Shader, multiple maps or multiple materials of layers, those multiple beat maps, multiple images as the textures, or colors if you're going to use just the colors, materials on an object, or use different materials for different parts of an object. Okay, let's go ahead and continue a little bit. This is about the light, just to get all type of tips. Another important aspect to consider. Okay, so it's still providing some value, and I believe it's pulling those values already online, because it's kind of try to conclude it for us, but we're pulling some more and getting some more information. Another important aspect to consider when adding multiple lights to a scene is the use of global illumination. Global illumination is a technique used to simulate the way light interacts with the surface in a scene, including indirect lighting such as reflection, refraction, and diffuse interreflection. Implementing global illumination can greatly enhance the realism and visual quality of the rendered image. Okay, so AI just explained to us what is the global illumination for me without even asking it in one response. And so if I would ask right now, before creating the second light, or even before creating any light on my 3D rendering scene, if I'm going to ask, go ahead and create the global illumination, it's going to tell us as response, probably, oh, you know what, this process is so complicated, this scene requires a lot of knowledge, go ahead and read a lot of books. The reason why it's doing that, or get some consultation, because you cannot add the global illumination to a scene without adding the light. So you gotta proceed step by step. So at least you gotta be knowledgeable about the topic. You gotta understand the processes at least on the basic level. So hopefully you understand. Before creating global illumination lighting, you first want to create basic lights, at least 2 lights, at least 1 light, but 2 lights will be better. Then you want to create materials such as colors. That colors can be applied to the 3D shapes, such as 3D primitives, 3D objects, whatever you're using, but 3D primitives as basic. And then you want to also do the textures as the images, and then of course you want to create the light before that, and then probably multiple lights, and then you're going to create the global illumination in the end. Okay, but before that, as you can see, it's utilizing, as it tells us, it's utilizing the reflection, refraction, diffuse maps, etc. So you got to create first reflection and refraction before asking the global illumination again, and before you're going to create after you're going to create the light, after you're going to create the methods of the refraction and refraction. Otherwise your code is not possible, because it's not going to compile, because the global illumination is not possible without those values, because global illumination is based on those values, on those properties of those algorithms and those approaches of 3D rendering. Okay, features. Hopefully guys this makes sense. There are several algorithms that can be used to implement global illumination, such as path tracing, bidirectional path tracing, photon mapping, and radiance caching. Each algorithm has its own strengths and weaknesses, and it's important to choose the right one for the desired effect. Okay, it can be rendered faster or slower, can deliver better quality of the image quality on the final render. This is what I learned through the computer games. It's also worth noting that global illumination, or GI, can be computationally expensive, and it can take a long time to render an image. The reason why I believe as a software developer, as a game developer, because whatever, and as a gamer and 3D artist, because it's going to apply the algorithms to every single element, as the AI already explained to us. You gotta apply that light, the global illumination lighting, to shadows, to the materials, textures, to all kind of maps. Make sure that you apply that, took as consideration, and revise your code. To reduce the computational expense, it's recommended to use techniques such as adaptive sampling, denoising, and progressive rendering. In conclusion, adding global illumination to a scene is an important aspect of creating a realistic and visually pleasing image. There are several algorithms that can be used to implement global illumination, such as path tracing. As again, there are several algorithms that is already known and utilized heavily in 3D rendering industries, but you can come up with your own algorithms. It doesn't matter that you come up with your own algorithms, but those type of algorithms is already available and it's easy to utilize. Okay, so several to implement global illumination, several algorithms such as path tracing, bidirectional path tracing, photon mapping, and radiance caching. Each one has its own strengths and weaknesses. However, the global illumination can be computationally expensive. It is recommended to use techniques such as adaptive sampling, denoising, and progressive rendering to reduce the computational expense. Let's go ahead and ask a little bit more about the lighting. As you can see, we just learned throughout this video so much information, guys. Especially if you're a gamer, if you've never done the 3DS, 3D artist, 3D animator, never render 3D image, you're gonna if you only render the 3D as computer gamer, you already learn a lot of those terms, guys, that you're switching under visual settings in your option under the video games, under the computer games, just throughout this video. So don't forget to smash that like button. As you can see, I'm dedicating a lot of money, time, energy. Most likely this video will be like 5 hours or maybe 4 hours, just the first part, but a lot of information available to you. Alright, let's get back. Another important aspect to consider when adding multiple lights to a scene is the use of ambient occlusion, AO. Okay, and what is the ambient occlusion? Hopefully it's going to explain it to us. Ambient occlusion is the technique used to simulate the way light interacts with the surface in a scene, including ambient lighting and shadows. Implementing ambient occlusion can greatly enhance the realism and visual quality of the rendered image by adding more depth and dimensionality to the scene. Okay, it's kind of hard to understand for the beginner. Let me explain it to you what I learned as 3D artist, as a gamer. What is the ambient occlusion? So let's assume you're a graphic designer, or let's assume you know what is Photoshop. Did you ever create the inner and inner shadows when the object doesn't cause the shadows, but you can create shadows on the object, like inner, inside of that layer? So around the edges of that object, of that layer, it's creating the darker spots, like a border, like a edge. It's creating the part of the edge. It's a darker. Okay, and you can create the color. You can manipulate that shadow color in their shadow color in Photoshop, like make it dark, gray, and it's going to create. This is how in 2D in Photoshop you kind of creating like 3D text. Okay, and so pretty much this is what is the ambient occlusion. So what is the ambient occlusion? Most likely ambient occlusion, you can see like 3D object, assume 3D object, a square, okay, a cube. So every single edge of that cube, when there is an edge, when there is a two polygons, those two polygons stitched together and creating the edge of that 3D object, you can, in that edge, you can make it darker or lighter. Let's say if it's a metal and you drop that cube, so when it's going to hit part of that edge, when you're connecting those two polygons, or every single polygon creating that that edge, okay, while you're connecting those two polygons. When you're connecting two polygons in that cube, when you're looking at it as a 3D, it's connecting at least two polygons on the side and on the top, and it's creating those edges, right? So if this would be, let's say, a texture of the metal or a color of the gray, like a metal, but it's going to retrace specular, so it's going to act as a metal in 3D world, and you're gonna throw it away and evolve, and it's a couple times, or on an asphalt, let's assume like in real life. So you're gonna scratch those edges. The first thing was going to be scratch the edges, because edges will slow down the physics while it's going to roll on the asphalt, and then those edges will be lighter color, because if it's going to be the metal, it's going to scratch it, and when you scratch the metal, it's lighter color. That's why, guys, when I'm developing PC games, when I'm developing through the coding the game using some game engines, I'm thinking that our reality is pretty much programmed by the moon. I'm not sure why I'm thinking so, but this is what I'm thinking. Okay, maybe we're updated by the moon with part of the code that creating physics, materials, and all of this stuff, because the 3D is so close to our life, like unbelievable, guys. But when you're developing games, you're creating a static code. But imagine a time when AI, this is what I envisioned and was telling to my friends in 2007 when I started manipulation with the first 3D engines as a software developer, because in 2007 I learned my first computer language from my heart. So it was Visual Basic 6 by Microsoft, and I understood what is the programming language, and I started thinking programming language. So I started manipulating and using some other APIs, game engines, and what I learned, I'm like, okay, I'm creating this code like a static code, but imagine if the code will be dynamic, and when the AI will create the code, and this is probably our life, and there is probably a satellite they call a moon that updating us and creating us with the information of this coding, all these algorithms, and putting in our brains, and this is how we imagine. Sometimes people are saying it's a matrix. There's a possibility, because this is how the table is physical object. This is how you can program the table as a physical object in 3D world. So let's get back to the topic, to the example. When you're dropping that cube, it's creating the scratches. So those scratches create this, it's going to be lighter color or darker color. You can apply some 3D depth to it, lighter and darker color just on a single scratch, and it depends through the ambient occlusion. Okay, so you can create one scratch, you can split the pixels into 2 pixels, and then create lighter and dark and create some depth to the scratch. Okay, additionally, okay, even without the shadows, this is the fast method of the ambient occlusion. Pretty much is the fast method when you're going to mimicking like shadows is approaching in a lighted environment, 3D world, but it's not created by the light, it's not calculated by the light. This is what I learned. Ambient occlusion is kind of faster way to emulate the shadows on the objects, and darker and lighter spots through the ambient occlusion maps, such as textures, or those materials such as textures, such as images, such as bitmap. And so you can create some ideas darker and some ideas is lighter. Okay, let's assume it's black and white, so darker will be darker spots, lighter will be lighter. This is the same way when you're drawing techniques. When you're drawing, let's say, a cube, you're creating the darker spots and lighter spots. So those spots can be created without the light in 3D world, just using the ambient occlusion. This is what I learned. So it's like in Photoshop, when you're using the 2D world, you're using the inner shadows, or you can use manually to draw it, but you can apply the filter in inner shadows, and it's inside of that layer around the edges. It will create darker or lighter spots. You can select the color, okay, and it's going to create that depth, that ability of, like, it's a 2D object becomes a 3D object. Hopefully, guys, I explained to you as a beginner more than it's explained by the AI in our case. Okay, let's get back to the AI. In conclusion, adding ambient occlusion to a scene is an important aspect of creating a realistic and visually realistic image. There are several algorithms that can be used to implement ambient occlusion, such as screen space ambient occlusion, SSAO. So right now you're learning this is another way of the ambient occlusion, and a lot of games are using these methods. Under the video options, you can see video settings. You can see SSAO, enable, disable, and sometimes you even don't know what it is. It's a screen space ambient occlusion, and this is an algorithm that can be used to implement ambient occlusion and ray tracing together, and ray trace ambient occlusion, RTAO. So you implementing, it didn't explain to us those two terms. Tell us that screen space ambient occlusion, and I have no idea what it is, to be honest with you, and ray trace ambient occlusion, RTAO, but you can ask AI to define this, and it's going to define it for you. Each one has its own strengths and weaknesses. However, probably in terms of the rendering of the speed and quality, this is what I learned. When it comes to weaknesses and when it comes to cons and pros, or strengths and weaknesses, it's pretty much the quality of the final pixel in the final render and the speed. This is pretty much what it is in the when we're talking weaknesses and strength in terms of the 3D rendering capabilities. However, ambient occlusion can be computationally expensive because it's going to take longer and it's going to utilize more GPU cores or CPU cores, depends which approach you're going to take. In our case, I'm taking the CPU approach, so it's going to be CPU cores, CPU threads, not the GPU cores. It's called on the GPU shader cores, or on the NVIDIA it's called, on the AMD it's called GPU unified shader cores, on NVIDIA it's called GPU CUDA cores, which is the shader cores as well. It's recommended to use techniques such as adaptive sampling, denoising, and progressive rendering to reduce the computational expense, okay, when you're using the ambient occlusion. So another tip, great tip. Let's continue. So pretty much we are, guys, expanding our knowledge, and I'm learning with you, as you can see. So pretty much AI are going to give you a lot of books, a lot of knowledge, and pretty much it's behind your back 100 scientists in that topic. In our case, it's going to be computer scientists, software developers, ray tracing professionals, and a lot of books combined, compressed in couple sentences, and it completely makes sense, especially if you a little bit knowledgeable in terms of the topic. Maybe it's not going to make a lot of sense for you as ultimate beginner, but if you already a gamer, if you played a little bit with the 3D game engines, it's already going to make a lot of sense for you. And you can additionally ask the AI to define it for you to the point when it's going to define it to your dog or to your cat. Okay, you will understand it. But I'm not going to use my request as again because I'm recording in real time. I'm trying not to edit this video. Okay, hopefully guys I'm making sense. So this is going to be just one take. I'm going to show you my skills. I'm demonstrating to you my skills on all kind of industries, and as you can tell, I'm professional graphics designer, 3D artist, software developer, game developer, yeah, and PC hardware enthusiast, and I'm implementing all those skills. And when you're going to be knowledgeable on a lot of topics and in a lot of industries, with the help of AI, you can be untouchable. You can be just, guys, innovative to the levels like it's unbelievable. Okay, all right, let's get back to the AI. Another important aspect to consider when adding multiple lights to a scene is the use of motion blur. Motion blur is a technique used to simulate the way the fast-moving object appears in the scene by blurring the object based on its motion. So it's like if it's animated scene though, okay? So you're gonna blur it out pixel by pixel. Implementing motion blur can greatly enhance the realism and visual quality of the rendering image by adding more depth and dimensionality to the scene. So most likely motion blur is applied to a camera. Okay, so camera is going to look at it. You're gonna move the camera, so it's gonna start create the animation, or you're gonna move the object, but you still need to have a camera, and we did not yet created the camera. So as I told you at the beginning of this continue part, we gotta create the camera in our 3D world. We didn't create the camera. Most likely it's going to use the default camera in the code. I didn't study completely the code yet. I didn't implement it in the C#. It's going to be the part 2 of this video when we're going to implement all this knowledge into the C# IDE. In our case, it's going to be a Microsoft Visual Studio. And we're gonna learn exactly what the code is, and we're gonna start manipulating with it through that video. But anyways, this is what's up, guys. All right, so we need to have a camera. So motion blur is the filter, is the fact that you can apply to the pixels and create that effect. Okay, in other words, for the beginner. There are several algorithms that can be used to implement motion blur, such as camera-based motion blur and object-based motion blur. Each algorithm has its own strengths and weaknesses, and it's important to choose the right for the desired effect. Okay, important to choose the right algorithm for the desired effect. So it can be motion blur like that, motion blur all pixels, motion blur just limited amount of the pixels, all kind of different algorithms. You can come up with your own algorithms by taking the basic motion blur algorithm and advance it. Okay. So don't get scared, guys. It's not something like computer science, like rocket science. It's not like that. You can take a basic and you can advance. This is what is computer science, okay? It's also worth noting that motion blur can be computationally expensive and it can take a long time to render an image. To reduce the computational expense, it's recommended to use techniques such as adaptive sampling, denoising, and progressive rendering. In conclusion, adding motion blur to a scene is an important aspect of creating a realistic and visually pleasing image. There are several algorithms that can be used to implement motion blur, such as camera-based motion blur and object-based motion blur. Just like, guys, I explained to you a couple seconds ago. All kind of different methods, all kind of different approaches. Each one has its own strengths and weaknesses. So if you're going to blur a couple pixels, the processing will be shorter. If you're going to render all the pixels per each frame, final render, the rendering process will be slower. Hopefully, guys, this makes sense, because the computational time will be longer to apply those type of algorithms per each pixel. However, motion blur can be computationally expensive. It's recommended to use techniques such as adaptive sampling, denoising, and progressive rendering to reduce the computational expense. So as you can see, it's moving to the camera filter options. Okay, let's continue, and if it's going to do that, I'm going to add the camera to the scene, and then keep moving. Depth of field. Depth of field is also a camera settings, and we didn't create the camera yet. So I'm going to go ahead and create the camera, and then I'm going to create the material as a texture, guys. So look like it's the AI approach. As you can see, it's coming. It just shifted its approach. It's coming to filters, to the algorithms that can be applied to a camera view. Okay, all kind of different filters. It's called filters. It's called post-processing filters in game development. Okay, another important aspect to consider when adding multiple lights to a scene is the use of depth of field. Depth of field is a technique used to simulate the way that the lens of the camera affects the focus of the image. Implementing depth of field can greatly enhance the realism and visual quality of the rendered image by adding more depth and dimensionality to the scene. There are several algorithms that can be used to implement depth of field, such as bokeh, which is depth of field like at the distance is going to be blurred out, and the object that you're going to focus is going to be sharp in focus. An example. As a photographer, because I'm a photographer as well, guys, professional photographer, as bokeh depth of field and circle of confusion depth of field. Pretty much bokeh depth of field is blurring the pixels at the distance. Okay, it all based on the distance to the object and to the focus on the object. Each algorithm has its own strength and weaknesses, and of course it's going to be faster or slower, or higher quality render, or slower quality or lower quality of the render, as I already explained to you when it comes to 3D rendering capabilities when they're talking about strength and weaknesses. I think this is what AI means, and it's important to choose the right one for the desired effect. It's also worth noting that depth of field can be computationally expensive, and it can take a long time to render an image. To reduce the computational expense, it is recommended to use techniques such as adaptive sampling, denoising, and progressive rendering. In conclusion, adding depth of field to a scene is an important aspect of creating a realistic and visually pleasing image. There are several algorithms that can be used to implement depth of field, such as bokeh depth of field and circle of confusion depth of field. Each one has its own strengths and weaknesses. However, depth of field can be computationally expensive. It is recommended to use techniques such as adaptive sampling, denoising, and progressive rendering to reduce the computational expense. This is when it comes to ray tracing. It's fastest approaches. Let's go ahead and ask continue for the last time, and I'm going to switch the topic. I'm going to ask to create the camera. Look like it's talking about the camera techniques. In addition to all these techniques mentioned above, there are many other techniques that you can use to enhance the realism and visual quality of your rendering image. But it's focused on the camera now, but it's also focused on the enhancing quality of the final image as 3D render image, such as volumetric lighting, fog and atmospheric scattering, subsurface scattering, and etc. and etc. Each technique has its own strengths and weaknesses, and it is important to choose the right one for the desired effect. It's also worth noting that many of these techniques can be computationally expensive and can take a long time to render an image. A final render completely makes sense, just because it's going to pretty much add the complexity to a scene through multiple algorithms, and the processing time on the CPU or GPU will take longer, and the final render will take longer of time to render each frame if it's animation, or a single frame if it's static image. To reduce the computational expense, it is recommended to use techniques such as adaptive sampling, denoising, and progressive rendering. In conclusion, adding multiple lights to a scene is an important aspect of creating a realistic and visually pleasing image. There are many techniques that can be used to enhance the realism and visual quality of your rendering image, such as global illumination, ambient occlusion, motion blur, depth of field, and many more. So global illumination and ambient occlusion, it's not the camera post-processing filters, but motion blur, depth of field is a camera effect, requires to have a camera, and many more. However, many of those, global illumination and ambient occlusion, this is the techniques for the lighting, as we already learned throughout this video. However, many of these techniques can be computationally expensive. It is recommended to use techniques such as adaptive sampling, denoising, and progressive rendering to reduce the computational expense. It is also important to test the performance and quality of the rendered image with the different techniques to find the right balance between performance and quality. Alright. Conclusion, kind of repeating itself. We're done. So I'm going to go ahead and ask the code to extend. We're going to come back to all of this. I'm going to go ahead and ask first to extend code and create the camera. Extend code and extend code and create a camera for the final image render with the final image render saving capabilities, which will be bitmap. So it's going to generate the bitmap while final, as again, when you typing this long sentences, you want to make sure it completely makes sense for the AI and can complete the request, while final image render can be previewed before saving, before the saving it into the image file. Okay, I think it makes sense. Here's an example of how you can extend the code to include the camera and the capability to render and save the image. So right now I want to see what is rendering in real time. I want to see it through the camera, of course, makes sense, right? In our real life as a human beings, this is our real world. The camera or eyes, if you're a human, this is how you see, but in a computer you see it through the camera. You gotta create the camera in some 3D world, because computer, everything in 3D world. So as you can see, it's extending. Let's go ahead and have a look how it's going to extend. Most likely is again it's going to start talking about blur effect, depth of field, and some other camera post-processing effects. I'm not looking to do that. I'm gonna probably use couple continuous, and hopefully we're gonna do some more requests before it's gonna cut us out. So guys, look like I'm gonna split those videos on multiple parts. I decided not to combine this through the YouTube video editing, those two parts. It's going to be a second part. This is what I decide. So we're gonna process, and this is going to be the research. Part 1, Part 2, Part 3 of the UHDking's ray tracing CPU benchmark. And the next topic will be development based on the research. So first we're gonna research with the AI as assistant, and then we're gonna develop as software developer by using that code, but pretty much copy and paste. Every beginner software developer can do that. And then we're gonna advance the code, fix the mistakes if we cannot fix with the AI, and after the first beta version of our software, of our application that's going to work, so we can test it, and then we're gonna advance it, and then I'm going to wrap it up, and we're gonna proceed. Alright, so continue. As you can see, it didn't finish. It was typing the method vector3 get ray direction, and it didn't finish. It even didn't close the method and didn't create the brackets. So continue, of course. As again, this is very important, why you gotta know the syntax. Hopefully guys, I'm not running out of the space. It's still recording. I'm recording as again in real time. So NVIDIA stocks, guys, will jump to the skies like you never saw, at least 2x, but I think 3x if AIs will be adapted, and I don't see the reason why not, because if you're not gonna adapt the AI as business, as individual, you're gonna be a person from the mountain, from the rock, and you know, the other people that will adopt the AI, and AI will be adopted, and the AI will become in form of the visual assistant. First it's going to be adopted through the chat, this is what I see it, but then it's going to become in form of the visual assistant through the glasses, okay? And this is going to be the first device, and holograms like from the movies, and this is where the first glasses and holograms through the AR technologies, when 3D is combined with the real life, and this is where we're gonna get as close as possible to think in the future, because people without these capabilities is pretty much not going to receive an information versus the people that with the AR capabilities plus the AI. This is what I envisioned all the way back in 2019 when the RTX 2018 when the RTX technologies or Turing GPU architecture or Titan RTX video card that I'm using today, or RTX 2080 Ti video card as a flagship, those two Turing GPU architecture as TU102 GPUs, but Titan RTX is TU102 GPU by NVIDIA featuring the full TU102 Turing GPU architecture, appear to the regular users. Not to the big corporation businesses, but to the gamers. And this is why, guys, I told you that we're going to combine visuals with the AI, and it's going to be another evolution. So right now it's through the chat, but then it's going to be through visual manipulations when you're going to combine the real life with the multiple 3D worlds, and you're going to start manipulating with those worlds and in real life, and you can open the boxes and nobody else can see it, and then you're going to grant the access to some multiple users to be able to see it, and some is not, even if they're using the same technology. It's going to be, guys, amazing. Okay, it's going to be close to the aliens as it can get, while we're going to utilize the AI and AR. And go ahead and check out my Bugatti video that was suppressed by the YouTube, and I believe by the Mark Zuckerberg, by the Meta, because they scared, by the Facebook negligent owner, Deceptor. They scared, guys. They scared because I already showed in 2019 the future, in 2020, 2019 the future with the my Bugatti videos, and in 2022, in 2021. Go ahead and check it out while I combine the real life with multiple 3D worlds, and pretty much it's the advanced AR technology. So I do not believe in VR. VR will be the losing technology, but I do believe in AR. Okay, and AR will be the winning technology, but as again, we're going to talk about it in the future, but this is related to this topic, guys. Okay, anyways, not related on a CPU rendering, but related on a GPU rendering, to the retracing cores to make it photorealistic, while you're going to combine the virtual items with the real life items to make it like, let's say you're going to sit on the couch, you're going to go to a furniture store while you're on the couch, and everything will be photorealistic. You're going to pick up the furniture exactly as it's going to look like in real life. Exactly. This is how the technology will be. Or you're going to pick the car exactly how it's going to look like, with all the details exactly one to one. Okay, by sitting on the couch. This is an example how we are going to utilize the AR technology in the future, advanced AR technology. I do not believe in VR technology. I do believe in AR technology, while combining multiple 3D walls with some permission accesses to users and with the real life. So let's see, continue. Okay, so it's creating the, as again, I did a mistake. It should be in a black box, so it's writing the code. So you gotta use this code right here. Make sure you're gonna put it right here to close this method. As you can see, it should be in a black box, but as again, maybe it's overloaded in the request as through their hardware capabilities in data centers, as again, but it's created. Yet I'm not studying the code, but I'm sure the code is going to be correct, guys. The AI is doing 99.9% of the code correct, and if it's not going to be correct, you can copy and paste the code snippet, and you can ask, could you please tell me where's the mistake, and define to your debugger through your IDE, and AI is going to tell you exactly what it is. All right, it's going to give you some tips and clues. This is for the beginners, programmers, beginner software developers. Okay, so it wrote as again in the code snippet as something that it's not even the comments under the C#. So do not put it in the C# because it's going to crash the application, and debugger is not going to know what to do. It's going to pretty much mark every single word as a mistake, because it's for human beings. If you're gonna create as the comments, you gotta put double forward slash, okay, based on the syntax. As again, syntax is important in the language that you're programming when you as a software developer and programming some application. But the AI, as again, is not limited to programming the application. It will create the music, arts. It's gonna replace the human beings, guys, and we're gonna utilize it, and it's going to be our assistant. It's going to be our best buddies. Okay, multiple AIs, and then it's going to be a single AI, and then it's going to be a general AI. They're going to a cabal, and it's going to program our kids from the birth. Right now, women programming our kids from the birth, and the cabal is manipulating the woman. It's promoting the cigarettes, wine as an alcohol on the woman. Then it's going to promote the climate change on the woman, and it's going to be program on the kids from the birth. But then AI as cabal will program that. This is why it's going to be very important to have your own AI, to train your own AI, and government doesn't understand that AI can be trained right now in the basements. And guys, I'm going to show you how to train your own AI while utilizing your machine learning hardware capabilities, which is machine learning hardware accelerators on your video cards, through your neural cores, through your tensor cores, whatever the technology you're using, whatever it's called, but it's going to be through a machine learning neural cores capabilities. Okay, it's going to be different videos available over the UHDking.com. Anyways, in this example, we added, as you can see, guys, I'm honest. I'm not here to make sure that you like me or such. I'm here to provide an information as informative as possible. Everything what I learned so far, over 10 years of experience while studying the topic, but I just jumped on AI for the past 2 years. As again, I was studying first the graphical AI, that rendering the pixels and such, through the Python and such, but then I learned that AI can be doing everything and anything thanks to the OpenAI and ChatGPT. Okay, in this example, we added a camera class that stores the position, direction, field of view. So it's a for the camera. Okay, field of view, as you can see, bokeh probably, and aspect ratio of the camera. We also added a render method to the retracer class that accepts the width, height, and file name of the final image. and it's already done. So width and height, so it's already created the an optional preview flag. So it's already created like a boolean, I believe, preview flag. But I wanna use the C#. I'm gonna ask it C# native libraries to create the bitmap in real time and render it. Inside the render method, we created a new bitmap. Alright, so it's created to store the final image and then iterate over all pixels in the final image, calculating the array for each pixels and tracing it to get the final color. Finally, we save the final image to the specified file name, and if the preview flag is set to true, we display the final image in the image viewer. And image viewer is going to be dependencies by the C#, so it's going to generate that bitmap. But is it going to generate in real time? I want to generate it in real time. I don't want to sit down and wait until it's going to complete and then it's going to show us the final image, because I saw some Java retracing that I was studying by a Polish developer back in 2020, and that's a very talented dude and computer scientist. He read 2 books before creating this project. One was by the Pixar and another one by another computer scientist. I read a short version of the book by the Pixar, and I was reading his papers. But so this is what I learned, and he doesn't show in real time rendering. It doesn't show in real time. It's showing when the image is done. Completely image is done. But I want to show the image in real time while utilizing the multi-thread capabilities. Can it be possible? I couldn't do that in Java. Didn't have yet a clue because I'm not solid programmer in Java. But let's go ahead and ask it. Please note that above code is just an example, and actual implementation may differ depending on the specific requirements of your project. Okay, we understand that. Let me ask. Let's continue first, and then I'm going to ask continue, make sure if it's going to provide us some additional tips. Okay, right now it's searching, guys. It's not showing us, so it's searching in real time what's going on, if it's any additional tips, because pretty much there is no other tips. It just completed our request. But right now I believe it's very expensive search, and this is after a couple of the searches. I don't know how many, 5 or maybe 10. You're going to be disabled. Your user account will be disabled for hour. Okay, under January 2023 free public beta version of the ChatGPT. Okay, this is how I see it as software developers again. This is how I would do it. Completely makes sense, because as I told you at the beginning of this video, that every single request take like 10 or sometimes even 100 requests on a Google. This is how much it costs of this company. Okay, so it's continue. It doesn't know how to continue, so it's not going to continue. So what I'm going to do, I'm probably going to stop generating, and I'm going to ask, because there is nothing to continue and AI doesn't know what it is. It's probably searching, eating a lot of resources, but maybe we even gonna be removed by 1 hour from the system. Probably gonna stop generating. There is nothing else it can provide us. I thought maybe it has some clue. It's always a great thing to ask, but I stop it. And what I'm gonna do, I'm going to go ahead and say, could you extend the extend the image preview code where image preview is by pixel, as I already explained it to you, by pixel, while pixel rendering process is multi-threaded, so it's not going to go through single thread. I learned some different Java code that was single threaded preview, and it like took forever, and it's only utilizing like single core of your CPU. It was under Java, a different computer scientist, not the Polish one. Polish even didn't show the preview. It showed the preview on the final image when it's done. Preview is by pixel rendering process is generating, we gotta specify for the AI, is generating the final image, and make sure that it is multi-threaded process. Let's see. I probably should say in real time. Oh, wait a second, guys. Wait a second. Wait a second, I didn't know there is on the bottom, and I stopped that thing. So actually it's answered the continue. I apologize, I misunderstood the question. But our assumption was correct. When I asked continue, the AI didn't understand. The code I provided is a basic. I was right, it cannot provide any continue, but it did some research of how you could implement the camera and the capability to render and save the final image in your retracing program, but doesn't fully utilize every thread at 100%. To do that, it's already explained it to us previously. You would need to use multi-threading techniques such as parallel for loops, thread pools, or tasks to distribute the workload of rendering the final image across multiple threads. But you can always ask a code snippet how to make it multi-threaded, guys. You can ask the AI, keep that in mind. So we can advance this code in the future. It's not a big deal. We're going to allocate the part of the code when it's going to do the real-time preview, and we're going to say go ahead and advance this code, make sure it's multi-threaded. Okay, you're going to ask this question of AI, you're going to paste the code, and it's going to go ahead and implement the multi-threading capabilities. I just give you a clue and tip. Here's an example of how you could use a parallel for a loop to utilize every thread at 100% while rendering the final image. So it's rendering the final image, as you can see. Here's an example of how you could use a parallel loop. So it's multi-threading capabilities to utilize every thread at 100% while rendering the final image. I could probably ask continue, but I asked a different question and we didn't scroll down, we didn't see the AI response. It's always try to make sure that it's not at the bottom. Extend the image, the AI response is not at the bottom, always scroll down. It's kind of, the user interface is a little bit cuckoo over here, but anyways. And it's kind of hard to save as PDF the way they created the user interface based in JavaScript, so it's cutting out the top portion of the screen to save the bandwidth while it's rendering in real time in the browser. But it could just render the whole deal once and keep adding to that deal. I'm not sure why they did it. So in this way, you cannot save right now this website as PDF to study offline. So they limited that. You cannot do it because it's hidden by the JavaScript. The upper portion of the pixels, whatever it was written on top, as you can see, it's hidden by the JavaScript. And if you're going to save as PDF, it's just going to save whatever you can see right now on your screen. It's not going to save the upper portion of the screen that already was rendered. Not going to save the lower portion of the screen what is have the data on the bottom. It's just hidden by the JavaScript, and they need to fix this. I think just adding the code to whatever is rendered, so it's not going to use their bandwidth of their servers. And at the same time, this is how I would implement this. At the same for the front-end user. At the same time, user as let's say software developer can save this as PDF. Otherwise, the user must come back to their website every single time. And just because when the website is overloaded with the requests, you cannot even pass to the point of over here to your account. So you won't be able to see your data, your researches. You won't be able to process to proceed with your project. So they need to a little bit tweak their website on the front end. This is how I see it as a web developer, as a software developer. Alright, guys? So it's very important when you're developing a project, always think in advance. Always think as multiple outside of your box, as multiple user capabilities, abilities, think thoughts, and etc. Okay? When you're developing the web project or application or software projects as a developer. as innovator. So here's an example of how you could extend the code. So I asked the AI, as you can see, I asked the AI extend the image preview code where image preview is by pixel while pixel rendering process is generating the final image, and make sure that it is multi-threaded process. Here's an example of how you could extend the code to include a live preview. This is exactly what I want. I didn't ask the live preview, but it understood of the image while it's being rendered. Look how smart AI, it's understood that it's live preview. This is unbelievable. While it's being rendered, yep, exactly what I want to do, live preview in real time. I probably should ask live preview in real time. I didn't phrase it correctly. But AI understood it exactly what I meant. This is how smart it is, by the way. And it's just a beginning. Just a beginning. This is not the final version, guys. The final version will be 100 times what you can see right now. And make sure that the process is multi-threaded. Okay? So it's creating the class retracer that is responsible, guys, for variables, and then retracer is responsible, the method is responsible for the render, look like for some construction, look like, and then the render right here, the method of render is from the render. So image width, height, show, viewer show, so it's gonna show in real time and it's gonna start rendering in real time. But is this a multi-threaded? Update the image viewer with the current state of the image. It's nice when it's commenting, and it's commenting like human being, like a not human being, like I'm not wasting my time to comment this for you. It's just commenting exactly to get to the point, without you know, that human hate and deception or negligence on base of the feeling. It's just unbelievable. That's why AI will replace the human beings at every field in every industry, guys. In this example, we added an image viewer object. Okay, this is dependencies of the C# to the retracer class, and we also added a live preview feature that updates the image viewer with the current state of the image while it is being rendered. Is it through every single core while it's rendering the every single pixel, or it's pixel by pixel? I'm just curious. We use a parallel loop, for loop. Yep, parallel means multi-threaded, parallel processing. For loop to iterate over all the pixels in the final image, and for each pixel we calculate the ray, trace it, set the color of the current pixel, and update the image viewer with the current state of an image. This way you can see the image being rendered in real time while it's being generated, and the whole process is multi-threaded. Exactly what I asked it to do. Absolutely, guys, absolutely amazing. Let's go ahead and ask continue. I want to hear the continue. Maybe it's gonna have some tips for us. I'm pretty sure it's gonna generate some tips for us. To further optimize the performance of the live preview, you can use techniques such as double buffering. So now remember the double buffering, triple buffering. I have no idea what it means in the computer games, so right now we're gonna learn it. So it's optimizing the preview in real time rendering. Okay, a double buffering, and also in PC games, video games, it's triple buffering, progressive rendering, and adaptive sampling. Adaptive sampling, it's I think it's going to pretty much create the anti-aliasing. It's going to make sure the pixels are not so sharp. Sometimes the edges will be sharp when it's going to be a line. It's not going to be just a solid line. It's going to be with some, if it's going to be, let's say, like a circle, it's going to be with the edges because it's created out of the pixels. Okay, I think this is why the adaptive sampling. If I'm not mistaken, as again, I'm not so into the, I never created by myself a 3D game engine, 3D render engine. So this is my ideas as a software developer, but as again, not as a professional 3D programmer, which is created couple 3D game engines or 3D render engines. I'm not one of those guys. So we are learning together. But as you can see, I have a solid knowledge in programming, 3D and graphics design. as well as some 3D real-time rendering through the computer games. Double buffering is a technique where you render the image to separate buffer while the current image is being displayed. This way, the image viewer is always displaying the fully rendered image while the next image is being rendered in the background. So double buffering, it means it's going to render the final image. It's rendered the final image. It's showing the final image while the next image that is still under the process is rendering. Okay, so that's why it's used the double buffer technique, and I believe this is the technique while it can update as an overlay in real time the next image on top of the, like a layers in Photoshop, on top of the previous render image, and it's doing that in real time. And I think that's why the double buffering technique is used. And triple buffering technique is used probably when the final image is rendered and it's rendering two images in advance, and then it's overlaying one image on another image. And maybe triple buffering is used when you're going to create an additional image post-processing effect or something like that. So first image is rendered with the, let's say, already rendered. Second image is in the process of rendering, and the third image is also rendering, but or it could be in memory, but it could be like a black and white effect that's going to overlay on a second image, and while second image additionally. So it's like triple buffering. This is what I'm thinking, but as again, I'm not sure. But you can define through the AI. It's going to be additional request, and as again, you learn that I cannot do a lot of requests because we're going to be cut out. So this, guys, this is going to be a second part, and when I'm going to be cut out, I'm going to start the third part if I'm not going to be done. If I'm going to be done, so we're going to be done with the pretty much brainstorming the project with the AI, getting some researches with the AI, and then we're gonna move to the next stage, which will be the developing application with the researches completed by the AI and us together. Okay, it's going to be multi-parts. This is how I decided to do it. I think this will be the best way to do it. And hopefully you're watching this. Don't forget, a lot of money, time, energy is invested. Don't forget, guys, to smash that like button, visit my sponsors. So at least I'm going to collect some pennies, and I'm going to use it towards you, towards my time, and we're going to do more of computer science in the future over UHDking.com YouTube channel, or some other YouTube channels that will be dedicated as UHDking going to proceed through the computer science. Some of the project will be artistic bytes, and this software, this application will be under the artistic bytes developed by the UHDking or by me. Okay, so this way the image viewer is always displaying the fully rendered image while the next image is being rendered in the background. So this is double buffering. Progressive rendering is a technique where you start by rendering a low resolution version of the image. We saw a lot of this through 3D rendering applications. When it's rendering like low quality, and then it's increasing the quality and much better in real time through a couple seconds, and gradually increasing the resolution. Yep, exactly what I stated, as the render progresses. This way you can see a rough idea of the final image quickly, and then gradually get a more detailed view of the image as the render progresses. Okay, adaptive sampling. So this is what is the adaptive sampling. Good thing that AI explained. Adaptive, so we don't have to define. Adaptive sampling is a technique where you sample the image at the higher rate in the areas where there is a lot of variation in color, and lower rates in areas where there is less variation in color. This way you can get a more accurate representation of the final image while reducing the number of samples required. Okay, let me read it again. I didn't understand it. Adaptive sampling is a technique where you sample the image at the higher rate Okay. So it's like at higher resolution. At higher rate means probably higher resolution in the areas where there is a lot of variation in color. So this is the anti-aliasing, guys. Whereas a lot of variation in color, you're sampling the image at the higher resolution, creating many pixels. So it's kind of make it many pixels in that area. So that's why the circle line, let's say if you're going to use just a line and draw a circle, it's going to be a pixelated, okay, because you're using the pixels. It's going to be squarish because square is a pixel, right? But when you're going to split those pixels into multiple pixels by creating a higher rate, which is higher rate of those pixels, which is the anti-aliasing pretty much. This is what anti-aliasing pretty much means. This is what you learn if you are a computer gamer. This way you can get a more accurate representation of the final image while reducing the number of samples required. Okay. It's worth noting that implementing these techniques may require a significant amount of additional coding and experimentation to achieve the desired result. So it's recommended to test the performance and quality of the rendered image with the different techniques to find the right balance between performance and quality. That's why under the custom I will allow the user, as again you always want to think about the user if you're innovator, developer, software developer, engineer, as a custom. So it's going to like adaptive sampling 2x, maybe 4x, so it's going to be a resolution by 4x at where the colors getting together, just like I explained in those terms. Let's continue. I'm pretty sure it has some more. Another technique that could be used to improve performance is to use a smaller resolution for the live preview and larger resolution for the final image. This way you can get a rough idea of the final image quickly and then save the final image at the larger resolution for a better quality. It's going to be like a brief preview or quick preview. Additionally, completely makes sense. Additionally, you can also consider using hardware acceleration for retracing, such as CUDA or OpenCL. As again, this is for GPU, and I'm not going to use the GPU, I'm going to use the CPU, so it's not going to be the case at the beginning of the UHDking's retracing CPU benchmark application. These technologies allow you to use the GPU to perform ray tracing, which can greatly increase the performance of the rendering process over the CPU, I guess the AI was about to say. And it didn't say so, but this is what I believe, yes. Finally, it's also important to consider the overall architecture of your renderer, such as data structure used to store the scene, the light, and the camera. Using efficient data structure and algorithms can greatly improve the performance of the renderer. Okay, in conclusion, there are many techniques that can be used to improve the performance of a live preview while rendering an image with ray tracing, such as double buffering, progressive rendering, adaptive sampling, using hardware acceleration, and efficient data structure. However, it is important to test the performance and quality of the renderer image with different techniques to find the right balance between performance and quality. Okay, let me stop over here, guys. Remember when Jay's 2 Cent, the guy kind of, he took like Jay-Z and 50 Cent kind of stick together. He's a computer guru, hardware enthusiast, as he called himself. Okay, on YouTube, he's big like Lannis Media Group, like Lannis, and the Nexus Gamers, okay, or Gamers Nexus. I forgot his name. What is exactly which one goes in order? I can look it up, but sorry, I'm just in my brain running multiple tasks in parallel right now. So they stated that, well, this is a retracing. This is not the rasterization. This is not the rasterization process. This is just a retracing. So they referred as regular 3D as rasterization process, while retracing as not rasterization process. So they picked up this dogma, this idea from some high school kid that doesn't know what it is, and they was pretty much zombifying millions of gamers, millions of people, with an idea that ray tracing is not rasterization. Ray tracing or 3D, before the ray tracing that used in video games, is rasterization, because the final image when it's rendered is rasterized as an image. Okay, and it is rasterization per each frame. Okay, no matter what it is, ray tracing or done through the vectors, but then the final image, the final render per each frame, before it's sent to your screen, is going to be rasterized. So this is the explanation when they zombifying as zombie repeaters on million of people, and those million of people as zombies, as again repeating that as repeaters to some other people. And this is YouTube, guys. This is a bad side of the YouTube, con of the YouTube. And over UHDking, you are learning exactly what it is, exactly sharing the experience without any of those marketing BS and such a stuff like that. It is exactly what you need to have, and the knowledge and the experience that I'm sharing with you because it's valuable experience. It is what it is. It was verified by me, and I'm trying to cut all the BS. So don't forget to smash that like button, as again throughout this video, even if you're PC gamer, video gamer, you learn a lot throughout just watching this part series. Make sure to watch every single this part series and try to learn as much as possible, even if you're not going to develop your own ray tracer, but you're going to learn a lot of data when it comes to 3D rendering, guys, in the video games, or if you're trying to be a 3D artist, 3D animator, or even graphics designer, or as a programmer. There is a lot of things will be discovered throughout my parts. So don't forget to smash the like button, share it with your friends. A lot of value, a lot of value. Pay back by watching at least my ads, guys, and positive comments. Thank you so much. Let's go ahead and continue. So finally, it's also important to consider the overall architecture of your render, such as data structure used to store the scene, the lights, and the camera. Using efficient data structures and algorithms can greatly improve the performance of the renderer. I have no idea what it's talking about, but we're going to find out. Maybe it's talking about some formats of the data. In conclusion, there are many techniques that can be used to improve the performance of the live preview while rendering an image with ray tracing, such as double buffering, progressive rendering. Progressive rendering, I think it's that rendering when it's doing the low quality and then it's improving the quality. I'm not sure what is exactly progressive rendering, but as again, we can ask to define adaptive sampling. Yes, we learn what it is. It's anti-aliasing, using hardware acceleration and efficient data structure. However, it is important to test the performance and quality of the rendered image with different techniques to find the right balance between performance and quality, because some approaches will be fast, some will be slow, some will generate higher quality, some will be generate lower quality. This is constant pros that I already explained to you when it comes to 3D rendering. Okay, guys, so let's continue. If it's going to give us an additional tips. Oh my goodness, it cut us, guys. I think it's cut us. That's it. We're done. Okay, it's reviewing the security of my connection. Okay, not sure what it was about. Let's go ahead and go all the way down, and I cannot go all the way down because the scroller is designed by the JavaScript, and you cannot save it as PDF. It's hilarious. So if you're doing the research, you cannot save the whole data as PDF. You can only see and save as PDF whatever you see. So the approach as front end user design, front end UX, and it's just BS, guys. Hopefully they're going to redesign this, as again just adding the stuff to the stuff that you already rendered is not going to eat up your bandwidth. And I don't see, yes, it will, if you're using it on a mobile device and you're doing the long research, if your chat is very long, it's going to use a lot of system RAM and a lot of resources of your device. I understand why they did it, but at least give us the option where we can choose. If the developers of the OpenAI is watching this, give us an option where we can choose, all right, guys? Because otherwise, give us an option. If I want to use your JavaScript Explorer, so I cannot save it as PDF, or give us an option where we can save the whole chat as PDF. Okay, in this way, through the JavaScript scrolling, you can save the resources of the device that you used to scroll for the front-end user. At the same time, user can at any time to save all the data of his research as PDF file, and maybe they're gonna make it as a professional version to make some money. Anyways, another technique that can be used, we already did so. Let's continue. Cut us out and check the security. So it's also checking the security, make sure the hackers are not spamming their service. I think this is why it was done like that. It's just checking, are you the same IP? Are your requests are not unlimited? Are you not you know, doing the false requests and utilizing the service by utilizing the data through the just, you know, spamming with the multiple false requests. That's a good idea. Maybe a lot of people in those bad countries, in those deceptive governments, or some bad actors going to use, like a hacker is going to use that, and they're checking, which is great. Anyways, another important aspect to consider when working with the multi-threaded ray tracer is synchronization and concurrent access to shared resources, as multiple threads are running simultaneously and may access the same data. It could lead to race conditions and data inconsistencies. To avoid this, you can use synchronization primitives such as locks. Wow, this is something new. I even didn't have idea about it. Semaphores, I have no idea what it is, and monitors to control the concurrent access to shared resources. It's probably through the multi-threading capabilities. Make sure that it's not going to mess up the pixels. You can, so one thread is not going to finish before the other thread. It depends on the complexity of that pixel. And put it the other thread instead of the other thread. The other pixel, and it's going to not render exactly what you're looking to render. It's going to be those type of pixels, but not in order. You can also use, this is what I'm assuming as software developer, so this is what AI explains. You can also use thread safe collections to store the scene, lights, and camera data. The concurrent dictionary, concurrent queue, the concurrent stack classes are example of the thread safe collection in C#. Never heard about it because I never developed such a multi-threaded applications before. So something new I'm learning as a C# developer as well. Additionally, you should also be careful when passing data between threads. To avoid data inconsistencies, you should use thread-safe data structures such as thread local and thread static to store thread-specific data, or use thread pool to pass data between threads. It is also important to keep in mind that multi-threading can increase the memory usage of your application, as each thread requires its own stack and heap space. Therefore, you should monitor that's why they're creating the heap space, like John Carmack did in ID Tech game engine by ID Software. Therefore, you should monitor the memory usage of your application and implement the memory management strategies such as object pooling to reduce the memory usage. So this is done by the professional developers, by professional programmers that know exactly how to create a safe code, how to create the safe application that's going to be manageable with proper garbage collector, and etc, etc, etc. I am kind of not so professional when it comes to that, so we're going to use AI to help us out, and this is a great thing because AI can help us out to improve the code. And again, this is where it's going to be part 3, when we're going to advance our code. Okay, after we're going to do the beta version of our application working with the basic code, with the foundation of the code. This is how I see it as a software developer, as programmer. In conclusion, and completely makes some sense, all right, guys. In conclusion, when working with a multi-threaded ray tracer, it is important to consider synchronization and concurrent access to shared resources, use thread-safe collections and data structures, and implement memory management strategies to reduce memory usage. Okay, so this is how properly to do multi-threading and make sure that you're going to utilize the memory correctly without memory leaks and proper memory usage, etc., etc., etc. I'm not so professional when it comes to that, but we're going to use it when we're going to optimize. It's going to be first, it's going to be optimization of our basic code, and then advancing that code. Part 4, advancing the code, and optimization will be part 3. Part 2 will be beta testing our application, and part 1 is right now researches, and part 2 will be development and beta testing as a developer while coding it. Let's ask continue if it's going to give us some clues. Another important aspect to consider when working with multi-threaded ray tracer is load balancing of the work among threads. If one thread is assigned more work than the others, remember I told you one pixel can be finished faster than the other one, depends the complexity of the algorithms while computing that pixel. It can cause a bottleneck and slow down the overall performance of the renderer. To avoid this, you can use load balancing algorithms such as task stealing or work stealing to distribute the work evenly among threads. In our case, it's going to be CPU threads, central processor unit threads. Task stealing is a technique where a thread that finishes its work early can steal work from other threads that are still working. Alright, so it's going to help it out in other ways. In other words, this way the work is distributed evenly among all threads and no threads is left idle. That's great. This is the proper multi-threading without any threads getting wasted or idling on the CPU or GPU. Depends which approach you're taking towards the ray tracer. In our case, it's CPU because it's a CPU benchmark. But as again, GPU benchmark is faster. Everybody understand that. As I already explained it, GPU, the flagship GPU is at least 50 times faster than flagship of the CPUs in 2023. And even if the CPU is using 128 threads, the ADA GPU architecture, AD102 GPU by NVIDIA will be at least 50 times faster than the latest AMD Threadripper CPU with the 128 threads. Believe me, guys, even two of them, it's not going to match. It's going to be at least 50 times faster. This is what I learned through the 3D rendering applications such as Blender when it comes to render on the CPU versus GPU. Okay, so when a thread finishes its work, it can steal tasks from other threads. This way the work is distributed evenly among all threads and no threads is left idle. Another technique is to use a task scheduler, which is component that assign tasks to threads. The task scheduler can use various algorithms to distribute the work evenly among the threads, such as work stealing or task stealing. So we gotta create a task scheduler that's going to control which thread are idling, and if it's finished the work, go ahead and help it out to the other thread to finish the work. It is important to know that the best load balancing algorithm will depend on the specific requirements of your project and the characteristic of the scene you're rendering. You may need to experiment with the different algorithms to find the best balance between the performance and the quality. In conclusion, when working with a multi-threaded ray tracer, it is important to consider load balancing to distribute the work evenly among threads, and you can use load balancing algorithms such as task stealing or work stealing, or use task scheduler to assign tasks to threads. The best algorithm will depend on the specific requirements of your project. Alright, let's continue if it's going to provide any other tips for us, but I understand it's providing the tips towards the multi trading right now. I'd focus on that. and I'm gonna keep moving. I asked just to create multi-threaded sample that going to create the live preview, but it's the AI just went and straight into multi-threaded um, discussion, which is important just for me is that I understand the best way to use the approach to the multi-threads. This is very important, especially in such a scenario when rendering the pixels. That's why the Polish developer that developed JavaScript excellent multi-threaded application, when it's creating the live view, it's not using the multi-threading because it probably didn't create all of this. Okay. Anyways, another important aspect to consider when working with a multi-threaded ray tracer is the thread management and communication. Exactly what we read. Thread management refers for creating, starting, and stopping threads, while thread communication refers to exchange of information between the threads. So this is exactly what that Polish developer didn't develop. Actually, he developed when it's processing the pixels, the amount of pixels, but when it's putting it into the final image, it's not multi-threaded process. But this AI just explained to us, the ChatGPT in this example over this video, how to create it and how to make sure that even when it's creating the live preview, it's utilizing the multi-thread. So completely multi-threaded application will be as result as reflection. To manage threads, you can use the threads class in C#, which provides methods such as start, join, and abort methods to create start and stop threads. You can also use the thread pool class, which is built-in thread pool that allows you to queue tasks to be executed by a pool of worker threads. To communicate between threads, you can use the log keyword to synchronize access to share resources, or you can use thread safe collections such as concurrent queue or concurrent dictionary. You can also use events, delegates and callbacks to notify other threads of changes or to pass data between threads. It is important to keep in mind that creation to many threads can lead to thread contention, which is when multiple threads compete for the same resources and slow down the performance of the renderer. To avoid thread contention, you should use thread pooling, which allows you to reuse a fixed number of threads, or use a task scheduler, which assigns tasks to threads. So most likely I'm going to use the task scheduler. So it's going to analyze the data, analyze it, how much which pixel, and then it's going to like how many pixels, etc. Data, and then it's going to split and dedicate to threads. But most likely I'm probably going to try to use all kind of different approach to find out the best approach in my case. Probably this is what AI is going to say. In conclusion, when working with a multi-threaded ray tracer, it is important to consider that thread management and communication. You can use the thread class or thread pool class to thread management and use the log keyword, thread safe collections, events, delegates, and callbacks for thread communication. Avoid creating too many threads. Use thread pooling or task scheduler to avoid thread contention, not connection. Okay, well, a bunch of words that I never know before because I wasn't that deep into the multi-threaded application. So this is pretty much was the part from the programmer or for multiple programmers, multiple software developers, that profession is just for multi-threading in C#. And AI studied them for sure. Another important aspect to consider when working with multi-threaded ray tracer is the optimization of the code. Ray tracing is a computationally intensive task, and even small improvements in the performance of the code can have a significant impact on the overall performance of the renderer. One optimization technique is to use vector instructions such as SIMD, single instruction multiple data, or AVX, advanced vector extensions. This is on a CPU, and I'm going to use the AVX instruction to utilize the CPU to its full potential and features on a CPU in 2023. It's AVX and AVX2 instruction, and now it's even AVX 512, I believe, on the latest Intel CPUs, but disabled on the latest AMD CPUs in 2023, that distributed to the desktop users in form of the Ryzen series on the AMD. This instruction allows you to perform multiple operations at once, which can greatly improve the performance of the renderer. Another technique is to use data-oriented design, which is design technique that focus on the data and how it's organized rather than the logic and how it's implemented. This can greatly improve the cache locality of the data and reduce the number of cache misses, which can greatly improve the performance of the renderer. Another technique is to use multi-level BVH, bounding volume hierarchy, or KD3, K dimension 3, never heard of it, to accelerate the intersection tests of rays with a scene. These data structures divide the scene into smaller regions, allowing you to quickly eliminate large portion of the scene that do not intersect with the ray. As again, if I said never heard of it, you can ask the AI to define it. I'm gonna do it because we're gonna be limited on our video, but you got an idea, guys, right? Wow, this video is already over 2 hours, I believe. It's important to know that the best optimization technique will depend on the specific requirements of your project and the characteristics of the scene you're rendering. You may need to experiment with the different techniques to find the best balance between performance and quality. In conclusion, when working with a multi-threaded ray tracer, it's important to consider optimization techniques such as vector instructions, data-oriented design, and acceleration data structures like BVH or KD3 to improve the performance of the renderer. The best optimization technique will depend on the specific requirements of your project and the characteristics of the scene you are rendering. Alright, let's continue, and I think we're done in terms of the multi-threaded. I don't think it's going to give us any other great clues. So we created the camera. Now I'm going to create we created the secondary light through this video camera. We learned how to create the preview box of our real-time rendering, pixel by pixel. And the next thing what we're gonna do, we are going to probably wrap up this video, and I'm going to wrap up this video when AI gonna cut us out through the service. It's gonna say you gotta wait 1 hour. Because otherwise the service will be overloaded tomorrow when I'm going to start recording in the morning. But what I'm trying to do, guys, this video will be like probably 4 hours, but I'm trying to finish maybe in this part if it's possible. But we are going to create a material as a texture, as a bitmap, as an image, so we can apply material to the 3D primitives, 3D objects, and then I will try to implement 3D formats as the 3D objects, such as OBJ format, maybe, that is used on all kind of operating systems. So you can load any kind of OBJ file into the benchmark, and then you can apply the texture on it. This is what I'm trying to do. So pretty much I'm building my 3D rendering application. Jesus. In addition to the techniques mentioned before, there are several other techniques that can be used to optimize a multi-threaded ray tracer. Some of these include early termination. When tracing a ray, if the ray hits an object that is not transparent or reflective, the tracing of the ray can be stopped, as it will not hit any other object. because it's not transparent or retraced or reflective. This can greatly reduce the number of intersection tests needed. And I believe that NVIDIA is using this method a lot, actually. I think this data was pulled out from the NVIDIA manual somehow. AI studied them. I read this already through the retracing on the CUDA, through the NVIDIA manuals. It was in 2022 on ADA GPU architecture on the 8102 GPU by the NVIDIA. Something like that I already read. Something similar in terms of the meaning. Coherence rays. When tracing rays, you can use coherent rays, which are rays that are closely related to each other. This can greatly reduce the number of intersection tests needed. Okay, as again I stated, it was done by the NVIDIA, but it doesn't mean that I'm gonna use it, guys, for those who's curious, okay, regarding any of the copyrights. It just approaches that AI is explaining to us, the human beings on the planet Earth took before, and AI learned based on those experiences. Okay, object space shading. Instead of transforming the ray into object space for each object, you can transform the object into ray space, which can greatly reduce the number of transformation needed. Compute shaders. Compute shaders are specialized shaders that are executed on a GPU, which can greatly improve the performance of the renderer. Compute shaders is when you multiply multiple maps, multiple textures, multiple images, multiple bitmaps into the final bitmap image and apply it to the 3D primitive or 3D object. As you can see, it's executed on the GPU. Okay, most likely we are not going to use it. Denoising, so it's when you're blending multiple maps, multiple textures, multiple bitmaps, multiple images, whatever you want to call it, through some techniques such as transparency, alpha channels, etc., or color pick. Denoising. Denoising is technique that reduces the noise in the final image by averaging the samples of the same pixel. This can reduce the number of samples needed for the final image. Makes sense. So denoising, we're going to use the denoising probably, because when you're using retracing, you want to use a lot of denoising. Hopefully the denoising is possible on the CPU retracing. It's probably going to be way slower than GPU, but hopefully it's possible. As again, I never developed any retracing capability on the CPU. This is the first time. I played a little bit in Java on this Polish developer, but a lot of things he didn't comment. So I was learning as I went and proceed with the code. But over here, a lot of things are commented by the AI, which is unbelievable, guys. It is important to know that the best optimization technique will depend on the specific requirements of your project and the characteristics of the scene you're rendering. You may need to experiment with the different techniques to find the best balance between performance and quality. It is also important to regularly profile the code to identify the bottlenecks and optimize the performance accordingly. So you gotta troubleshoot the code, you gotta debug the code, and you're gonna through runtime to test, to beta test. Immediately after you're writing, you wanna check your CPU utilization, in our case, GPU utilization, and how it's react. Make sure it's going to only utilize the CPU and completely what I'm looking as multi-threaded 100%. And you wanna test those type of methods, those type of classes. Make sure everything is chicky-picky, okay? Everything is rock and roll. In conclusion, there are many optimization techniques that can be used to improve the performance of multi-threaded ray tracers, such as early termination, coherence rays, object space shading, compute shaders, and denoising. The best optimization technique will depend on specific requirements of your project and characteristic of the scene you're rendering. It is important to profile code regularly to identify the bottlenecks and optimize the performance accordingly. So pretty much we learn how to optimize multi-threaded retracer. Okay, we got all the information. I can ask continue, but I'm pretty sure there is nothing to continue here. But let's go ahead and have a look. Just to wrap it up. Yeah, there is nothing to continue over here. Right now, I believe it's searching. And this is going to be a costly request for them. Now it's answering. And very soon it's going to cut us out. In addition to the technique mentioned before, there are several other techniques that can be used to optimize a multi-threaded retracer. Alright, let's go ahead and have a look. So this was actually a great thing that I did the continue. So always try to do the continue, especially when you are not recording, because you always can come back in 1 hour and see, but in this type of approach, you can develop a better applications or get a better answers by the AI that's going to provide better value to you as individual, no matter what kind of project you're running. Pre-calculation of some values, like inverse of matrix of pre-calculating the parameters needed in intersection test or lighting calculations. Have no idea what it is. Probably John Carmack knows what it is. Reusing memory. Memory allocation is the allocation can be time-consuming operation. By reusing memory that is no longer needed, you can reduce the number of memory allocated and the allocation operations. So pretty much this is like a garbage collector of the memory that is used for the operation tasks. This is what I believe. Okay, so this kind of makes sense. So you gotta be in control. You gotta develop where you're gonna offload this the memory that is used, and make sure that you're not gonna leak that memory, that you're not gonna load on top, even if you're not using it any longer, but it's still going to utilize that memory, and eventually it's going to crash and overload all of your available memory. This is how I see it as a software developer. Task granularity. One way to improve performance is to increase the granularity of the task by breaking down the work into smaller tasks. You can increase the parallelism and reduce contention for shared resources. Adaptive sampling. An adaptive sampling algorithm, this is, guys, like anti-aliasing, I believe, can be used to reduce the number of samples needed to produce the final image. This can greatly improve the performance of the renderer. We already heard this, so it's repeating itself, but it's kind of summarizing for us. Using the cache memory. You can use the cache memory to store frequently used data, and you reduce the number of memory accesses. Okay? It is important to note that the best optimization technique will depend on the specific requirements of your project and the characteristic of the scene you are rendering. You may need to experiment with a different technique to find the best balance between performance and quality. And also, you should regularly profile the code to identify the bottlenecks and optimize the performance accordingly. In conclusion, there are many optimization techniques that can be used to improve the performance of a multi-threaded retracer, such as pre-calculation of some values, reusing memory, task granularity, adaptive sampling, and using the cache memory. The best optimization technique will depend on the specific requirements of your project and the characteristic of the scene you're rendering. It is important to profile the code regularly to identify the bottlenecks and optimize the performance accordingly. So pretty much we already heard this. This is just in a different sentencing. Okay, we're done here. So the next step, if I'm going to optimize, I'm going to, as I told you, optimizing the code is going to be part 3 of the stages, not the part 3 of the video, but of the stages of this development, of this transparent development. So the next thing, what I'm going to do, the next thing I'm going to create logical. What is the logical next step? I'm going to create the texture bitmap as material. So extend code and create texture as material that can be applied on the 3D primitive or shape, but I think it's called primitive, so not shape. On 3D primitive in the ray tracing scene. Completely makes sense. Guys, I'm gonna grab a water. I'm losing the voice. Let me grab a water real quick. 1 second. I believe it's already 3-hour recording. I'll be right back in a few seconds. Nice. Just water with a lemon. No more coffee. It's nighttime. It's like almost 5 a.m. over here. And we started like what? It was almost like 2 a.m. So it's already like 3 hours. Wow, it's generating a lot of code for us. A lot of code, guys. We're about to study it. Look at this, and it closed it even. Wow. This time I just generated a lot of code and then stop. Look like the service maybe is not ultra busy, and it's gave us a little bit more characters that we can use. And again, this is the ChatGPT January 9 version, which is free public version on January 2023, January 9 2023 version. Alright, so I asked to extend the code. The good thing that is you can see the previous code, which is nice, and create the texture as material that can be applied on the 3D primitive in a ray tracing scene. So to add textures as material that can be applied to 3D primitive in a ray tracing scene, you can create, see, like I'm asking great questions, guys. Even if I'm not ray tracer professional, I didn't create any ray tracing engines before, but AI completely understand me and it is even phrasing the way I am phrasing, which is completely makes sense for it. Because if you're not going to ask the question correctly, it's going to rephrase it correctly. So to add the texture as material that can be applied to a 3D primitive or 3D object in a ray tracing scene, you can create a new class called texture material that inherits from the material class. This new class will have additional properties such as texture and UVW to store the texture image and the UVW coordinates of the texture. Here's an example of the texture material class. So it asks us to create a new class called texture material that inherit from the material class. So it's extending pretty much the material class, and it's creating an addition version of that material class by extending it with some more features. But what I'm gonna ask the next AI to create a 3D material, 3D, not the material, but to create a 3D primitive and apply that material to apply like basic test.gpg texture or test.png or something like that, or BMP. It depends what is the dependencies of the image class of the C#. I didn't use it for a long time. I forgot. I didn't use it for the image manipulation for a long time. I think it supports the BMP, GPG, PNG. The new class will have additional properties such as texture and UVW to store the texture image and the UVW coordinates of the texture. Here's an example of the texture material class. Great, so we can use it in our code if and then call it but texture sample, but where's that ability to load that image? In the shade method of the texture material class. So it's very important when you're talking to the AI. I'm just trying to do it as fast as possible, but it's very important to study every single line of the code to understand it and to ask it accordingly. It's also another tip for you. But as again, I'm trying to read it at the same time. I'm not trying to make it like a couple days. I'm trying to make it a couple hours, the whole process of the researches, and what I'm going to use to complete the final application. In the shade method of the texture material class, shade method, it calculates, it's probably in the bottom, the UVW coordinates of the intersection point, samples the texture at the UVW coordinates, and applies the texture color to the final color. So instead of applying color, it's loading the texture, picking up those pixels of those colors and applying color pixel by pixel of the color to the 3D primitive, just like it did the whole color, the solid color, but in our case it's going to be all kind of different pixels that's representing that image. So this is how I understand that. So you can use the texture material class and the trace ray method to apply the texture to the 3D primitive. So here we go. Data 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 data, return texture material shade, data data data, but where it's loading the image, the bitmap. It's worth noting that you need to improve the texture class and a sample method to sample the texture image. Here we go. We need to load the image. Also, you need to change the way of passing the material to the primitive to use texture material instead of material. Also, you need to change the way of passing the material to the primitive to use texture material instead of material. Okay. In conclusion, to add texture as material that can be applied to 3D primitive in a ray tracing scene, you can create a new class called texture material that inherits from the material class, which is extends material class in other words, and use it in the trace ray method along with the texture class to sample the texture image. Okay, let's see. So texture material, trace ray, but where's the texture class? Didn't see any texture class. Should I ask continue? Let's go ahead and ask continue. I think it's done. It probably should create some more. Oh my god, that's it guys, we are limited. So look like it's going to be over for this part 2. So researches will be 3 parts. Okay, so I'm going to come back look like tomorrow, hopefully. We'll see how this video will go. Please support me, smash that like button, support me, positive comments, and visit my sponsors guys. If you can donate me something. And I'm going to create more tutorials like that. We're going to develop more applications. We're going to develop more website when every single idea will be explained with step-by-step instruction for the beginners. I'm not going to go and I'm not going to pretend like I'm knowledgeable and such. I'm going to not only explain to you step-by-step instructions, but we're going to go and we're going to make sure that everything is right on. Okay, and let me see, I think, let me refresh, but when this message is, look like we are overloaded. Let me try to continue. Look like we overloaded our 1 hour request that allocated to us as a user, and after 1 hour we can do some more. But sometimes you can trick it like this, switch to a different chat, come back and try to continue, and sometimes it's working, but I believe they're ready fix that. Yeah, it was a bug and they fixed that. So that's it, guys. Too bad that you cannot save it as PDF. I explained it to you why, because they're cutting out with JavaScript and they're not rendering the above or below. And hopefully they're going to create in the future ability to save it as a PDF. Okay. Otherwise, it's you cannot study it online. Too bad, too sad. Anyways, my name is UHDking, or I play 4K, aka I play 8K, aka I play 16K. For those who didn't know, I was the first YouTuber that recorded the world's first 16K video resolution gameplay in video games, and the first 15,360 pixels by 8,640 pixels gameplay. That is 132.7 megapixels that was ever uploaded to the YouTube back in 2015, but over the official UHDking.com YouTube channel back in 2016, before anybody else did, like Linus Media Group, like Linus and anybody else. All right. And they copied me 6 months after, exactly the games that I did as demonstration over UHDking.com. But anyway, smash that like button, share it with your friends, guys. I will see you in part 3. So together we are developing UHDking ray tracing a CPU benchmark. Okay, and hopefully this benchmark will be popular. As you can see, I'm trying to make the development process as transparent as possible, and this is going to be my contribution to the PC hardware enthusiasts, PC overclockers, software developer, computer scientist, graphics designer, 3D artist, so we can test our processors in our systems, and hopefully I'm going to create it on all kind of different platforms. Probably C# was not the best choice. I know, but Microsoft is improving C# and hopefully very soon C# will be deployable on all kind of devices just like Java, and is going to work. Alright. As again, UHDking.com. Hopefully you enjoyed this video. The audio track on the background is all right reserved. There is no royalties can be claimed. I own the commercial license, purchase it from the composer and directly, and I have the license. Have a good day, good morning, good evening, and I will see you guys till the next time.